Okay, we're going to talk about integration laws in just a second. I'm going to refresh your brain on limit laws and derivative laws, just a couple of them. So notice if you have the limit, ooh, I almost forgot, as x approaches c, 5x plus 10. Well, these both have a 5 in common, and the 5 can be factored out. In fact, you could do this. The limit as x approaches some value. You could do 5 and then x plus 2. Well, now you've just got this coefficient that can be brought out in front. So now you have it written like this. Okay? Okay, likewise, let me just cover that up. If you have a function, you're going to take the derivative. Well, there are two pieces there. So one of the derivative laws is you can actually take the derivative of the first. So the derivative, so I'm going to call this h of x, and I'm going to call this one f of x, and this one g of x. Remember we did those tables? Well, then h prime of x is equal to f prime plus g prime. So you take the derivative of each individual one. So h prime of x would equal 10x plus 10. Okay, so you can separate, oh, the other thing I forgot with that limit law, so once you get it to be 5 times the limit of x plus 2, now we can use the sum limit law. That's the same thing as saying is 5 times the limit of x, and remember this is all as x approaches a value, plus the limit of a sum is the sum of the limits, and then you do the distributive. 5 times the limit of x as x approaches c plus 5 times the limit of 2 as x approaches, that's an arrow, not a plus sign. All right, so now I'm going to erase all this stuff. Is that all the way? And now we're going to talk about integration laws. So first of all, there are two different terms. So we could take the integration of two terms, but notice they also have a negative 2 in common. So we could do this first step of factoring out a negative 2, and then what would be left would be x to the negative 2 plus 10x to the negative 5th dx. And then this negative 2 would be brought out in front. All right? But now we have two terms. So the integral of a sum is going to be the sum of the integrals. So, but remember, negative 2 is on the outside, so we're going to do negative 2 times, well, we're going to take the integral of x to the negative 2nd dx plus the integral of 10x to the negative 5th dx. Well, notice this one has a constant, so I'm going to bring that 10 out because remember the limit law, the constant comes out in front. All right, and then it makes it a little bit easier to integrate. You don't have to separate this out, but these would be some of the limit laws. And once in a while, separating them out into two different integrals and at the very end putting them back all together sometimes actually helps. Okay, so let's go ahead and finish this off. So we still have negative 2, and now I'm going to put the big parentheses. So this integral, when we add 1, that becomes negative 1, divide by negative 1, so this is going to be negative, and because the x is negative 1, we're going to put the x down here. So think about it. 1 over x to the second, right? When you work backwards, if this is the derivative, the original would have been negative 1 over x. Because remember, whatever on a rational equation, whatever this sign is, the derivative will be the opposite sign, and whatever this denominator is, the new denominator will be one integer higher for the exponent. So when we work backwards for the integral, this x was positive, so the integral will be negative, and since this was x to the negative second, when we work backwards, it was x to the first. All right, and then that's a plus c because it's indefinite. So I'm going to put this in parentheses, plus we have a 10 on the outside of parentheses. This is x to the negative fifth. So x, remember you add 1, so x to the negative fifth, we're going to add 1. Negative 5 plus 1 is negative 4. And then that's going to be x to the negative fourth. So we'll put x to the fourth down here. So this becomes 1 over, there's a negative sign up front. That negative sign we're going to move to right outside the fraction. So negative sign 1 over 4x to the fourth plus c. All right, and these plus c's, if we wanted, we could have put outside here. And now we're going to multiply negative 2 times each of those. So we can say f of x is equal to, well, negative times negative is positive. So this one is 2 over x. This is negative times positive, so this is subtract 10 over 4x to the fourth. Oh, look at this, is going to simplify. Then we can put the plus capital C. So our final will be f of x is equal to 2 over x minus, these both have a 2 in common, so 5 halves, and then x to the fourth is in the denominator, plus capital C. So using the limit laws, now do we need to do all that? No, you could have gone directly from this, but once in a while using the integral laws actually makes it easier to kind of pull things apart and do them separately. All right, that's it for this one.